Hello everyone, my name is Vikas Shukla and the intended audience of today's video are the fresh software graduates in computer science or computer engineering courses. So this is the kind of the video I would have liked when I passed out for my computer science. And if you are not very cautious about the choice of your career, uh, your uh, your friends could be rising higher in your career, and you would be wondering where I made a mistake. So there are few general comments, and then there are few specific comments which I have listed out in this whiteboard, and we'll go through all of these. Make sure you listen to me all the way to the end, even if not all of it is relevant to you. But I will find that you will find at least couple of statements or couple of my dialogues useful for your career. So the first my general statement is that try to find a job which is a little more difficult than what your capability is. So don't try to go for something which is very tough, very that you will find that because you know your capability where it stands. For example, something which is very tough mathematically or solving the problems requires expertise in multiple domains and you are not very good at it. For example, you find it very difficult to comprehend a software or write a program which could span maybe like looking at 30-40 files at a time. You are better at looking at one small section of a code at a time and you can only do that much. So don't go for those kind of very complicated software that requires a much in-depth study or something like that. Try to find a job or a work which is only a little bit more difficult than your capability. Don't go for very simple or very easy job, but then you will not have job satisfaction. You won't enjoy that either. And even though it's very hard and it's not always possible to do that kind of thing, but at least you can give it a try. So that's one general comment. The second very important concept thing that you need to keep in mind is don't go always with the job that you land with the campus interview. Most of the fourth year students during sometimes like their third or fourth months in their fourth year, they start getting campus interviews and you are allowed only one or at the most two jobs in the campus interview. So the people who are interviewing you, they need someone to fulfill certain positions, typically not a very high-end position. But when you are in the fourth year, what all you are trying to do is just grab any job that comes into your hand. And you pick it up without giving much thought because you have been, or your parents have been spending money on you, on the education, and you want to grab whatsoever comes in your hand. So you are tempted to do whatever job that comes in. For example, the kind of the job that you could be landing into has to do with the QA kind of job or something like a simple testing or maybe some simple graphic design or it could be just doing some data entry in the software in a database or something like that. It may not be very designed, and in the initial 2-3 years of your career is very crucial. Whatsoever you learn or whatsoever you set the kind of the direction, that's something that you will be doing in many more years to come. So don't just grab the first job that you get at the campus. Even if you get one job at the campus, keep looking at, and that's what will be the topic of my more coming topics, that try to look for the other jobs even if you have landed into one job in the campus interview. The third comment is that you certainly need, if you are doing a computer science education, you certainly need to understand what is C, what is Python, and other operating system, possibly Linux. You should have your hands on the Linux operating system and many more things. So these are certainly you should have all these things. With that said, let's move on to see what, and then there are few other comments is you need to fulfill a demand in the industry and the lack of the availability of the of that kind of the skills that the industry demands. So one way to find that gap is by looking at the jobs that are high paying. And that's how I have listed out these jobs. The jobs that are high paying, it means that they have a very good demand of that job and there's a lack of the available talent for that particular job. So, and you need to see if you could come in to fill up those jobs. So let's move on to this thing. The first job that comes to in my mind is the chip design and verification. So a lot of the first two of my listing, it has to do with the hardware. It means now all those hardware also need some kind of the software skill at that. So in the chip design and verification, this is possibly the job that anyone who has done a computer science and computer science and engineering graduation will better fit, because you should have a course in switching theory and logic design, and you should be liking that job. If you like that course, then you probably would like this kind of job. They would like to have a certain level of competency to take you into that kind of job, because a chip design is something which does not like any kind of error, because when they design the chip, any kind of error can lead to a $5 million of loss, because a single mistake means they need to redesign the whole chip, and that they love. So you need to be something who is very methodic, very systematic, and you feel that if you do any kind of job, then you don't make any kind of mistake. That's something you need to judge about it. But there's a very big demand into it, and if you are interested in, unfortunately, this kind of job will usually not be good for if you are something like doing only pure computer science. By pure computer science means you are only studying computer algorithm and you are not into switching theory and logic design or electronic design, and you have no interest into this. You are coming from a non-computer science background, for example, a mechanical engineering background or other. Not that it's wrong into this, but if you are interested, you will have to get interest into the electronics and chip design things of this. So it's very high paying. Chip design is not the only thing that requires computer science knowledge. A big part of it is the verification, which means you will be doing a lot of writing scripts to verify a chip design, and that's where a lot of computer science skill will come into effect. It's very high paying. What the problem with this is that very few companies will be looking into giving that kind of job to freshers. You will need to apply for into the companies which does computers, chip design and verification. For example, could be the companies which makes the tools for the chip design and verification, FPGAs, for example, Xilinx or Intel, Altera, or other companies who are designing chips, would be Qualcomm, maybe Samsung, Nvidia, and AMD. All those companies are doing a lot of chip design and also associated chip verification. Once you get into it, try to learn as much. But even before you can go into this, you will need to prepare yourself to make yourself competent enough to show that you have the required skill or willingness to do into this. So the way to do is to learn about the Verilog language, which is used for chip design and verification. System Verilog may be VHDL, and I have some videos about how to learn the Verilog, System Verilog, and things like that. And once you have done that, you may want to actually download your code into something called an FPGA to see that your code works into its actual hardware, where you download your code and see that it's actually working. For example, you could write a simple code to see an I2C communication or a serial port communication and see that the code things work. The next thing is Linux and embedded software is also related to the hardware, where you try to write a software which actually goes into some hardware. There's a big demand for it, and it's very high paying. Not all people get the opportunity to write software that actually goes into the hardware, and that's something you will be looking for. Try to find a company that does that kind of work. Again, if you do not get that kind of opportunity, you yourself need to find a hardware, for example, an Arduino or a Raspberry Pi or Freescale's IMX6 board, a board where you can write, for example, the U-boot. So the U-boot, for example, it's a BIOS of the embedded software, and then you need to be very good at C. Then you can learn about the Linux, then you can move on to write some Linux device driver code, or you can use how to use a device driver in a Linux application. The embedded software, again, it comes into two parts. One is for the smaller microcontroller, which goes into the smaller devices like an air conditioner or home automation system. That's one area you could do. You could, for example, start learning from Arduino, and once you have mastered it, you can start applying for the embedded software position. So that's one area you could focus on. The third one in my list is an emerging technologies, which by emerging technologies, it will keep changing with time, but the most recent one, there's a lack of the skills for those kind of emerging technologies. And then you could learn from it. For example, it's AI, machine learning, image detection, newer technologies that's used in the Bitcoin thing. Though all of these are emerging technologies, to give you an idea of how image detection or automation is being used in a lot of newer companies, is, let's say there's a doctor's office and there are patients coming into the doctor's office, and the earlier method is they would just take your name, your credentials, your address, they will enter into their database, and then next time you come, they again ask your all those credentials match with your existing database. But using the image detection, they will have just a camera pointing to your face, and they could just learn by looking at your face who you are, what your name is, what your address is, and all they need to do is just verify your phone number and say, okay, I have rest of your old data. What it does is it brings efficiency to the process. So those are the kind of the things that's happening in AI, machine learning. For example, in the blood testing, if we could be taking a blood sample, and by looking at the image of that your blood sample from the microscope, it could learn and can get you the pathogen that's there in the blood or not there. So those emerging technologies have a lot of demand. People are using AI and the machine learning. It's a lot of data, and based upon the data, you keep changing your algorithm. It automatically adapts itself and makes it better over the time. So if you can find your interest, you can show your interest to what it has a lot of demand. The next in my list is the web security and server-related jobs. Again, this requires a certain level of competency, which you should understand, because if you are looking at the web security, it automatically means that you understand the network, what is network, how the server is installed, and all these things even before you go into the web security thing. It's a very high demanding in terms of it will require a lot of commitment from your side. You have to be very enthusiastic, very kind of a killing instinct. You should have a killer instinct to go after the network, see what can make it break or what can fix it. Next in my list is a web technologies, and a very big, a huge sphere. If you find it a little challenging, these things more challenging than you are capable of, or you think that it could be a little more demanding, then you could get into a lot of huge demand for the software, which is web technologies, Java, Python, database, front and back end, and all these things. You could fit into it. The key thing is just do not land into testing and QA type of job when you join any company, because there's nothing wrong with the testing and QA, and there's a huge group of software engineers who are required into the testing and QA. But if that is the kind of the things you want to do, then you should not go for these things. Just be satisfied with this. Be inventive in how you can bring automation in the testing and QA. Just see how you can keep improving of this. But if that's not if you think that you are a little better than them, try to fit into one of these Java, Python, and database kind of thing. But in those things, try to do something which is a little bit more challenging. For example, how you can make the whole thing more automative. You can automate more things. How you can do the things more efficiently. How you can make your database better designed so it can address not current but also future expansions and things like that. I'm not an expert on this thing, but I'm just giving a quick broad overall ideas of these things. Then you can also go into the graphics and other things, making front end look good. And also there are a lot of things that are required. For example, a search engine optimization thing, which also interact with the software engineer, how to make your website more responsive to the sales demands of the sales. So these are just a quick overview of what I think you should do, and giving an overall general overview of how you should plan your career in future. The one thing I wanted to add is that if you plan to be in the technology field or in the technical field, you want to be in a software engineer, you should extend your technology life by a little more instead of just half a year or 1 year, 2 year, and be tempted to become a lead or a manager. Try to extend its life by work at least for 5 or 7 years in deep technologies before you take up more managerial related jobs. Nothing wrong into it. If you are more interested into management sales, then you can jump early into the management field if you are not more interested into learning more technology. So these are some of my ideas. I would like to see your comments in the comment section.